Hello, hello, and welcome to Science on a Thursday afternoon. Thank you all for being here. I hope you had a great PE, those of you in my class, those of you from other classes joining us. Welcome to Science. Today we're going to be talking about activating yeast. It feels a little different than the previous science content we've been talking about, these larger sort of macro systems. Like the last time we spoke, we were talking about a whole ecosystem in the Monterey Bay kelp forest, and today we're zooming in on one organism in particular and thinking about what it needs to survive, okay? Over here, those are our materials today. You're gonna need a science notebook to take notes, and you're gonna need a pencil or pen, obviously, if your science notebook is on paper. Some of you I know have science notebooks on Google Docs, which is great, and you can type straight in there. And then here are our I cans today. I can make detailed observations of a scientific phenomenon, and I can make a claim that answers the focus question and support that claim with observational evidence. And this is kind of new territory for science because for actually the first time this year, we are going to be doing like a live demonstration and looking at some actual stuff. We've kind of been operating in the digital realm for the first couple of science lessons, but today we're going to actually look at like a real thing happening. And I will tell you what, setting it up and getting the timing right, as you can see by the timer behind my head, was stressful. Oh my gosh, it was stressful. Okay. Here's our word wall over here. Oh, these are the words that we've already talked about in this unit, thinking about the idea of system or component or ecosystem, and this idea that living things within the biosphere are going to need certain components or need certain things in order to survive, in order to make their system function, and how all of that, whether it's transfer of energy or interaction with the non-living components, how all of these things work together in order to create balance in an ecosystem. Today we're going to zoom in on one organism in particular to answer this focus question. What is needed to activate yeast from dormancy? As you can see, there's a supply list behind me. Now, you do not have to do this investigation in person if you have all of these things at home. Yeast, Ziploc bags to hold your stuff in, warm 40 to 50 degrees Celsius water, tools, some measurement tools to measure 5 grams and 50 milliliters, and also some sort of bowl or big mug or something to hold your samples in. If you've got all that stuff, you can certainly, before we get to the results, you could certainly pause this video, do it yourself at home and make observations based on what you see at home, and then come back to the video at the end and see if your results look the same as mine. I would highly encourage that if you want to take that on. You can also just follow along with me because I'm going to be doing this whole investigation right here and live. So, when we talk about yeast, okay, you may have heard the word yeast before, particularly if you do any sort of baking. If you're like one of those many people during shelter in place that decided they were going to take on baking some sourdough bread, for instance, or baking any bread that has to rise. The ingredient that makes bread rise, and we're going to get into the why, is yeast. I have a sample bag here. This is what 5 grams or just about of yeast looks like, and it's hard to tell because we're, again, unfortunately, in the digital realm, so you can't see the yeast up close, but it's kind of these little granule-looking things. They're very small. Here's my finger for scale, and I'm probably seeing like at least like 150 little granules of yeast just in the length of half my finger. So very, very small granules. If I spread them out, you can see a few there kind of up top, right? Very, very small, smaller than a grain of rice. And if you were with us in the classroom, which I'm sad that we're not, but if you were with us in the classroom, you'd get to use more than your sense of sight to make some observations. You could use your sense of touch and actually feel the yeast, and also you could use your sense of smell. okay? Because if I were to open up this bag and smell my yeast, it really kind of does smell like bread, okay? And there's a reason for that, and it's because a lot of bread's got yeast in it, okay? Because it's got to rise. So this idea of what we need to activate yeast from dormancy is going to be our focus question. Dormancy or dormant, and let's see, can I put it in the word wall live? Oh my gosh, I wonder if I can. Bear with me. I've never done this before. I'm going to see if it'll work. Let's see. Dormancy, a state of rest or inaction. Did it work? Oh yeah, it did. Incredible. Okay, so this word dormancy over here, a state of rest or inaction, it means it's not doing anything, right? We talk about, you might have heard that word before in relation to a volcano. A dormant volcano is one that's not currently erupting, right? Or one that currently doesn't have any, or isn't even close to erupting. It's really just kind of resting there, right? And that's an idea with yeast. Right now, it's not active. It's in a state of rest. And we need to think about what are the things, or what can we add to it to activate it and get it really working and get it alive, because it is a living thing. Yeast is a living thing. We'll get into what type of living thing it is later, but it is a living thing, and it just needs to be woken up. So put your thinking cap on and think about what are all the different things, all the different components that living things need to survive. Well, we need water, right? We need some sort of food source, nutrition, right? Plants, they produce their own food. They photosynthesize the sun's energy, and they make their own food. Consumers need to consume other organisms, and decomposers consume dead and rotting organisms, and they, expel out humus. Right, so the things that how we know something is alive basically is it drinking water in some way? Is it consuming food in some way, even if it's making its own? Does it have any sort of waste product? Right, you talk about the relationship between plants and humans, or plants and mammals, where we breathe in oxygen, or we breathe in air, and our lungs take the oxygen out of the air, and then we breathe out carbon dioxide. That's our waste product from our breathing. Okay, plants are the opposite, right? They take in the carbon dioxide from the air and they expel oxygen, which is why the more plants you have out there, the better your air quality is, right? So we want to think about, and we need to just think and really consider what's needed to activate yeast from dormancy, and how can we set up an investigation to test that out and figure out what things are needed to activate yeast from dormancy. First, the first thing we're going to need is we're going to need a control. Okay? With any investigation, we need to make sure that one of our samples, we're not doing anything to, that's our control. Because let's say it wakes up just by being in a Ziploc bag, for instance, right? If we didn't have one that all we did to it was put it in a Ziploc bag and leave it there, we have no way of knowing whether it's the Ziploc bag that is causing our yeast to activate or it's something else, right? So we're going to have a control, okay? Let's think about water. Let's think about water. And you'll see a little hint behind me that I said 40 to 50 degree water. There is a component of warmth or of temperature that activates yeast from dormancy. But we're going to make sure. So what we're going to do is we're going to test one with, or we already have, it's sitting there, I'm staring at it. We have tested one sample with the same amount of yeast as this one, 5 grams. And we're going to put it in 50 milliliters, which is why I put it right there, 50 milliliters of water. And then we're going to actually kind of let it soak in a little little water bath here, all at room temperature. I can check my thermometer currently. I'm going to show you what's over here in a second. Okay, just bear with me. Currently, our water temperature is, I don't know if you can see that, 25 degrees Celsius. Okay, but I do want to test this warmth idea. So I'm also going to put, again, same amount of yeast, same kind of bag, same amount of water, 50 milliliters. What I did was I took our syringe and I took our water. Okay, many of you have done this in past investigations in class before. Put the tip of the syringe in and measure out 50 milliliters. Okay, and then what I did, I'm going to show you now, is I put the 50 milliliters of water in our yeast. Okay, now it's got water. Give it a little shake. Really mix it up a little bit there. Now it kind of looks like a sludge. Okay, there's a little bit of bubbles that I'm noticing. You see those bubbles up there too? Okay, from the kind of the activity of me shaking it up. Gave it some bubbles. That makes me think that sort of the surface tension of the water is still there. Yeast doesn't break surface tension, which is good to know. So I'm going to test it with, this was room temperature water, but I also tested it with warmer water. Let me see our thermometer here from the warmer water. Our warmer water is now at this point about 40 degrees Celsius. Well, it's going down quite a bit now, but it was up above 40 degrees Celsius right when I took it out of the water. Okay? And the last thing, we talked about water, we talked about temperature. Okay? The last thing is we want to think about food, a food source. Does our yeast, is water or warm water enough to activate our yeast? Or does it need some sort of food source? Does it need some nutrition? So I'm trying the most easily accessible food that I have in my classroom, which is a granola bar. Chocolate chip. It's got some oats, got some chocolate chips, got some sugar. And we're going to see if yeast likes that granola bar. So before we get down to it and make our observations, okay, this is the part where we're going to write down, is once we observe and talk about what we're seeing from our now 17-minute timed yeast here. How are we going to know? How are we going to know that our yeast is active? What things or what observations might we see that tell us that our yeast is active? Currently, I'm not seeing a whole lot of change to this in the 1 minute or so since I put it in the water. But what change might I see if our yeast was active? Would we see, we might see a reaction of, it might get hotter even, or it might get colder. There might be a temperature change. We're just looking for changes from the norm. Okay, right now this is kind of the norm, or our room temperature control already looks different than our unwatered control. There's nothing happening with this. So we've already seen a change, but do we know that this is active? And again, this goes back to this idea of having a waste product, right? When any living organism consumes energy or uses energy, there's a byproduct to it, right? In our case, it's, waste products, right? Go into the bathroom. But it's also, like I said, the carbon dioxide gas that comes from our exhale, right? Those are all waste products. Once we've used up the oxygen or the caloric energy, the food energy in what we eat, we get rid of what we don't need. So we want to look for some sort of waste product. Are we ready to see? We've now been in, of course I just reset it as I grabbed it, but if you look back at the thing, we had been in there for about 18 and a half minutes, okay? Probably it'll get up to 20 by the time I write the chart out. So what we Where did my dry erase go? There it is. What you might want to put in your science notebook is a little bit of a graphic organizer here. Okay, keep it simple. And actually, we don't even need that bit. Okay, so we'll have our control. We're going to use H2O, which is the molecular formula for water. H2O, I'm going to put room temp for room temperature. And then I'm going to go here, H2O warm, and H2O warm plus food. Okay, and for each of these columns below, I want you to write in what you notice and what you see. What you notice and what you see. Okay, here we go. We're going to lower a little bit and then we're going to move a little bit. Let's try this. I've never done this before. It's like having a steady cam. Ta-da! Oh, we got to go lower. There we go. Okay, at this point, before you look at anything, if you want to try this investigation on your own, pause the video. Pause the video. Go try it. See, here's my setup. I'll show you my setup. So I've got our yeast with water, and then this water is the same temperature as the water that I put in the bag. Okay, so this is our room temperature control. Okay, so let's look first at our control. This is nothing to it but putting it in a bag. Does it look any different than when we saw it earlier? If not, you can write no change. This is dormant yeast still. It doesn't just magically wake up on its own. Okay? This is our room temperature yeast. Okay? Give it a closer look. I don't super want to drip on my computer here, but we can see, again, seeing a little bit of those bubbles, but not many. And it's still kind of got that sludgy consistency to it. Okay, so that's the change by putting water in. Do we think it's active at that point? Is there an evidence of some sort of byproduct? Or does it just kind of look like it's wet and it's just a mixture? I think we can safely assume that it's some sort of mixture. Okay, so now here is the currently at 42 degrees Celsius warm sample. And I'm going to compare it to the room temperature sample. So here's hot on this side, and then here's room temperature on this side. Any change that we noticed, that we can see? Not really, huh? Not really. So I think we can safely say that it's not just water that activates yeast. It's not just warm water that activates yeast. We need something more than that. These are still dormant. Okay, now let's look at, wait, let me get the right ones. There's room temperature, there's heat. Now let's look at the heat plus the food. This was about, it wasn't even a whole granola bar because I'm going to be honest, I ate a bite or two. This was 2/3 thereabouts of granola bar. Now, first thing, tons of bubbles, right? Tons of bubbles all over the place. Okay, compare that to the room temperature. Has it gotten bigger or smaller? It's definitely increased, right? It's gotten bigger. You can look to the side there and look, check that out. That's the shot right there. Okay, both of these bags looked, I pressed the air out of both of these bags before starting this experiment. So there's a definite change here with food plus hot water. Okay, why is the bag puffy? Does anyone have an idea? Why did this bag end up all puffy? if you said it's because there's some gas being released, you are absolutely correct. And believe it or not, this gas being released, one, this is evidence that we've activated our yeast. There's something happening here, okay? There's definitely something happening here. This bag does not puff up on its own, all right? There's definitely gas being released here. That is our waste byproduct from our yeast consuming that granola bar. It's using that energy in the granola bar and it's eating it up, okay? And the gas being released, believe it or not, that is the same carbon dioxide gas that we release when we breathe out. How fascinating. Okay, so let's think about our claim and evidence here. Okay, answering this question, what is needed to activate yeast from dormancy? What were all of the components that we put into this bag in order to activate our yeast and get it moving, get it cooking, get it going, okay? Waking it up. What were all those components? And then what is the evidence? How did we know? What change occurred that tells us that something happened? What is the change that occurred that tells us that this yeast has woken up? That is going to be our exit ticket for this lesson. Okay? Thank you for tuning in. I actually think I timed this out pretty well. All things considered, it was not easy to have this set up like at the perfect time to then start the video, to live stream, and then be done and ready when I needed it. I kind of think I nailed it, guys. I don't know about you. So, those of you Glenview 5th graders, do the exit ticket on Google Classroom. Writing groups C, we'll raise back up here, ta-da. Writing groups C and D, I will see you in the Zoom room in just a little bit. Then we have book club at 2:15, and then we are on a 3-day weekend. Lucky you. I have to go to work tomorrow, but y'all don't. So enjoy the day off without me, and thank you for tuning in. I appreciate it. Good luck. Happy science.